Hi everyone, you are welcome to Easy Science channel. IL Excel Physics WPH13 01 January 2021 Part 1 of the Unit 3. Okay, shall we start with the first question? Let's begin. A student used the apparatus shown below to investigate the relationship between the acceleration of an object and the resultant force on the object. So you have to understand the picture. Air from blower, air track, glider, string, pulley, slotted mass, and they have mentioned diagram not to scale. Okay, so if it is to the scale, you can take any measurement by ruler and do the calculation, but here it's not. The air track is, now A part is, air track is a long metal tube with holes along its length. Air from a blower enters the tube and escapes through the holes. Why? Minimizing friction between the glider and the track. So there's a friction in between. To avoid that, air from blower is coming. So it's a good idea for you to understand how to minimize friction in a tube. Okay, so the student released the slotted masses and the glider accelerated along the track. Describe how he could determine the acceleration of the glider. You may add to the diagram. So anything you can add. Now, first he must do what? He has to do first, he have to write the equipments. Okay, he has to mark 2 points on the air track and measure the distance between the 2 points using the meter when the stopwatch is open. When the stopwatch crosses the first mark, he has to note the time and stop when the stopwatch is stopped. When it passes P point, he has to make another mark on the stopwatch. Then by the difference he can calculate the time taken for Q to P movement. Okay, so the glider is initially at rest. That means initial velocity going to be 0. If initial velocity is going to be 0 and you want to measure the distance, if you know the time, in previous videos I have explained you nicely. If so, you have to use S equals UT plus AT square. You can follow my videos and learn previous parts, but I am still recalling them, and then that is the equation you have to use here. S equals UT plus half AT squared. U is going to be 0, means UT is going to be 0. So and then you have to subject A. Okay, finally you have to repeat this experiment at least 5 times to avoid your anomalous readings, and then you can calculate the mean, and that will be increase your reliability. So the problem is, now you know what's happening and everything, but when you come to write, you are thinking and you don't know to arrange your sentence in a point form. So they are given 5 marks. 5 marks means you have 5 minutes, as well as you have to write at least 5 sentences. That means 5 points you have to write. So now think carefully how to organize your practical. So I have written clearly for you to understand, for you to read. So you have to learn everything I have written on the paper then anytime you can come to this and read all. So now you learn how we are writing. We are writing one by one. He has to mark any 2 points first on the R track. Why? To measure the distance between the 2 points. By what? A meter ruler. So you name as PQ. Always ask why, what, when. Then you will know what to write. Then he needs to start the stopwatch when the glider crosses the first mark and stop the stopwatch when the glider crosses the second mark. Why? You want to find the time taken. So since the glider was initially at rest, initial velocity would be 0. Why you are mentioning this part? Because you are using, your idea is to use to find S. So then you are going to use S equals ut plus half at squared. So when initial velocity is 0, this part is going to be 0. Very easy to calculate A. So when you subject A, it is going to be 2s over at squared when you cross multiply. So subject A and calculate the value of acceleration. So he should repeat the experiment. Why he should repeat? To get more accurate results and also to avoid anomalous results. Finally, you are calculating again the mean of all to increase the reliability more. So you write what you know. Okay, then that's it. Okay, now go to B part. Now what is happening? Another student complete the investigation. He is recording his results. Now what he is putting 20 and he can add another 20 and make 40. Another 20 and make it 60. So he can replace 20 and come up to 100. Or else he can remove this 20. If you have 40 mass, so you are bringing that 40. Again you are removing this, can put 60. Like that, it can, he can finally come up to mass 100 if he has mass 100 weight. Okay, so he is accordingly he is measuring force and acceleration. So he is plotting. He plotted some of the results. So question is plot the remaining points because they want to find whether you know to plot. Okay, so they are giving 2 points. So you know it is, first of all, you should know one square, small square, the value of small square in both axes. So you calculate. So now 6 to 8, 0.2 divided to 10 parts. So 10 parts equals to 0.2. Then 1 part 0.2 divided by 10, that is 0.02. So you know 1 part value. So likewise you can measure all the other points. Here also same, every time you should know 1 square the value. Okay, then easy to plot. First you have to take x value, then go to y value. So first force is in your x direction. So the student concludes that these results do not show that the acceleration of the glider is directly proportional to this force. Now what happened? He is thinking, oh my God, my best fit line is not going through a origin. That means the acceleration of the glider is not going to be directly proportional now. It is not passing through the origin. If to be directly proportional, your graph should go through the origin. It is not so here. So what does his teacher? Now part C, the teacher explained why. Teacher is explaining the resultant force to be directly proportional. And teacher is giving another good hint, the total mass of the system must be kept constant. So how the student should keep the total mass of the system constant during the investigation. So it's a general knowledge. How are you going to keep the total mass? Everyone knows, no? So you should know. Do you need to know physics to write this? No. Then how are you going to keep the total mass of the system? Okay? So you're not changing the mass. That is the only thing. You are having a fixed mass. So 1 mark. You write. He can keep the mass of the system in constant relationship by placing the same mass on the slotted mass angle, which was previously removed from the glider. So now he can keep it constant. It's not going to change. So that's what I advise all the children. Your answer is always at hand, or they are giving a hint for you to think. They might give a very big story or very big picture that you don't know at the beginning of the question. So you don't worry about that. When you go to the question, you realize that is simply a formula they are asking or the define. They will say mostly define. So very simple. So rather than spending more time on their nice pictures, same time you go and read the questions to last part. Why I am telling you read all and get the good idea what they want. When you read all the parts A, B, C and D or E, you will realize what to write. Otherwise, if you read A and answering, B and answering, then when you come to C or D, you will realize, oh, I have answered D part, I have written in A. Then you cut. Don't do that. You have to be very calm and quiet, no stress at all. You know 100% sure. You have confidence on your physics paper. It's so nice. So don't get stressed about the pictures or whatever you get at the beginning. It is to give you a rough idea what they are asking. So better to, when you read all questions, one by one when you answer, you will realize, oh, this is the story. Okay, so stick on to that. Okay, so I am giving all the hints for you to get A grade. So now you know, I think you know C. So it's very simple, general knowledge. Then it's done. Okay, we'll move on to question number 2. A student determined the refractive index of a transparent material. Now now this section is from light. So now you should know about light equations. The student had a semicircular block of the material. So transmitter material is there. When you see incident rays going on surface, you know when you draw the normal, you can mark C. Normal at this point. So you know C. So you take the protractor. If you measure C, you are getting critical angle of this material. Okay. So refractive index. Okay. So refractive index. You know the formula? When you know the critical angle, what is refractive index is 1 over sin C equals 1 over n. So refractive index going to be 1 over sin 38. So they are asking determine the refractive index of the transparent material using measurements from the diagram. So you know critical angle is 38. So sin C and 1 over n is going to be 1 over sin 38, 1 over 1.62. When you calculate from the calculator, you are getting refractive index for the material is 1.62. This material. Okay. So you write that. Then student is repeating the process of a second material, okay, that different material, and her measured value is critical angle 41 plus or minus 0.5. He got 41. Okay. Now see, calculate the range of possible values for the refractive index. So when you see plus or minus here, it is the angle, two angles you can get. 41 plus 0.5, 41 minus 0.5. You have upper limit and a lower limit. So you get both limits. So you can calculate like previous way. It is 1.51 and 1.54. Okay. 54. And see, it is line between these. Now what is happening? We have 38. Okay. Here 38. Now, you know, refractive index, now value of angle I is 64, value of angle I, and angle R is 36. Okay. So what is in sin I over sin R? It is sin 64 divided by sin 36. That is going to be 153 here. Okay. The student had a rectangular block, transparent material she made. Now here critical angle, you know, for this is, for this material, you know, it is 1.5, between 1.51 and 1.54. They are asking the range. So remember, always you have to write what they are asking. I am telling every time in my videos, don't write what you know, write what they are asking you to do. Range. So underline range. So we have to give range. How can I give range? Yes, they have given plus or minus. That is how you think. And you are writing this. Now when you go to C, it is not refractive index. It is incident ray. They have given I and R. There's another material. Now, how to find, if it is not C, how to find the refractive index? You have to go to sin I over sin R. Sin 64 divided by, sorry, it's angle R 36. Over here, sin 36. Okay. This should be sin 36. Okay. This should be sin 36. So then when you calculate sin I over sin R, you will get 153 for this material. So now we know, before we got this. Yes, we understand. This 153 should lie over here, in between 151 and 154. So therefore, your answer is, since 153 lies within the range, this block is made of the same material as in the block P. Remember the two equations. Refractive index is given by sin I over sin R. At the same time, if you know the critical angle, refractive index is given by 1 over sin C. Sin C equals 1 over A. So remember those two equations about refractive index. It's done, and we'll move on to part D. The student used rays of white light. Explain why using monochromatic light would increase the validity of the conclusion made in C. Okay, what is monochromatic light? Is the light having contain one wavelength. Okay, whereas white light has a mixture of wavelength. So mixture of wavelength is travel through a glass and different wavelengths refract at different angles. So if mixture going through a glass, what will happen? Different wavelength will give you different angles. So monochromatic light is better, no? Rather than getting a white light. So you are getting 3 marks. So you have to write this in proper manner. So I have written for you, the monochromatic light has single wavelength, whereas the white light has a range of lambda. So the different wavelengths would refract differently. So white light will give uncertain value of angles. So using monochromatic light would increase the validity of the conclusion made in C part. Okay, that's done. Now moving to E part. The photograph shows a spectrometer. This can be used to measure angles when investigation refraction. Now you know collimator, transparent material, telescope, everything is there written. Maybe you have not seen. No problem. You go and read. Light emerges from the collimator is a narrow parallel beam. Okay. They are giving everything. So you don't need to worry about the mechanism or anything. Okay. What you want, they are giving. A vernier scale allows the angles to be measured with a resolution 0.1 degree. You know that. What does this mean? 0.1 means in vernier scales you are getting for 1 decimal point. Now see, protractor, actually it is 1, not decimal. 1 whole number. 1, 2, 3 like that. So resolution of protractor is now 10 times than the resolution of the vernier. Okay, when you divide by 10 only, you are getting 1.1. So resolution of the protractor is 10 times than the resolution of the vernier. Okay, using a spectrometer reduces the uncertainty in the value of the refractive index of the material compared with using a ray box and a protractor. They are giving a nice statement, true statement. You have to stick on to this statement. So if you don't know the answer, also you have to justify this by physics theories. So what is the idea coming to your head to justify this? What you should think? You have to give 3 points also. Okay? So hint, when the white light actually travels from the air to glass, white light is thick, very large diameter, whereas the ray box reflects light with smaller diameter and narrow. So that is the idea should come to head to justify this comment. Okay? So having that idea, you organize your answer. Writing the answer to the point. The resolution of angle measured with the protractor is 10 times greater than the resolution of the vernier scale. So uncertainty of the angle decreases. It's good. A beam from a collimator is narrower than from the ray box, which increases the accuracy of an angle measurement. Okay, so now you know everything. So you know how to write and how to organize your answers, how to use, how to think about, and how many points to write, how many minutes you are taking. Everything was done. So that is and that will be the end of the part 1 of the unit 3. I think all of you understand very well. Thank you very much. See you in next video, part 2 of this paper unit 3. Okay, until such time, study well. Have a nice day.